Hey there, this is Azadi Bogolubov from Degrees of Freedom. If you recall in the last video in this series, which was discussing how to create a REST API with Node.js, Express, and React, this code might look familiar. In this video, the task is going to be for us to swap this API out on the back end, what we currently have inside of the fitness server setup, which has these endpoints: get by ID, post, and delete. And we're going to swap this out in Java, still using the same React-based system with MongoDB. In the last video, I said I was not sure what the version of Mongo was. It turns out that when I did install this a few years ago, it was Mongo 4. I've since updated the system to Mongo 7, and it still works exactly as intended. So if you're using an older version of Mongo, no worries there, whether it be Docker based or via local installation. But I wanted to clarify that. So we're going to hop into IntelliJ. You don't have to use IntelliJ. You can use Visual Studio Code or Eclipse or whatever tool set you like. I personally really like working with the JetBrains suite, as it's a common user interface across the board, and it comes with a lot of handy pieces, but it does cost money outside of the Community Edition. And for Spring, doing work in the Community Edition becomes a bit trickier. So that's something to keep in mind. The first thing you might notice when coming to a Java-based Spring application is you have a whole different set of folders. You have .gradle, which is the build system here. You have .idea, which is going to be from IntelliJ. If you're not using IntelliJ, you won't see this. Your build folder, which contains all your generated classes, just like you see here with these classes. Only they're going to be .class files because Java uses an interpreter in between. These classes can be deconstructed and decompiled back into their components. For our purposes, we don't care about this, but it is worth calling out. So here you see a controller, an entity, a repository, and a service. We're going to start by jumping into the entity. The entity contains all the fields that we might expect from working inside of the other system. To put them side by side, what we'll see here was we had sets, reps, weight, name, date, and ID. Here we have ID, but we don't underscore it because Spring works on convention over configuration, and the way that things work when working with Spring Data's MongoDB setup is that you can actually call it ID and it'll work. And through the data setting here with Lombok, you get it for free, the getters, the setters, and knowing this is data. So you'll see in a moment, we'll see getters and setters. Those come for free through the metadata here. We're telling it again, we're working with a weight schema, weight schemas, which is plural, as this is what it's been stored as inside of MongoDB. If we go over to our application.properties, we'll see that we're still working with the same database. To compare and contrast this to the work we did in Node, we connected to localhost 27017 and we left it alone blank. Here we need to identify the database's test. So that's one difference. But you notice we don't have to deal with the full URL here, as it's a bit different and we don't have a promise-based system. So coming now over to the application settings. I'm going to shrink this window so I don't have to keep bouncing them back and forth, because I'm sure that's got to be annoying. So we're going to pull this down. Pull this a bit to the left. If I can, it doesn't appear I can. Okay, that's fine. I'm just going to give a new line here. There, now we can see everything. So here we had to do body parser, we had to tell it cores, we had to do all of our setup. Here for cores, what we have to do is add the cores mapping, use what's called a Java bean. Java beans are automatically configured at the app runtime. Purists would say put this into its own class. For the sake of simplicity, I'm leaving it here in the application class. And I'm telling it that when anybody from localhost 3000 calls the wait endpoint, whether that be the post, the get, the delete, that it is okay and allowed. So this gets us around cores the same way it did in Node. And then there's the line here to run the application, similar to what we have here in Node with the app.listen. So let's get down to the actual functional code. If we come into the controller here, you will see calls that look very similar to what you might see here with our app post, get, and delete. You see a get mapping with wait, and it produces JSON. The same with a get mapping by ID. And then another get mapping or post mapping for wait, which consumes JSON and produces JSON. What you might notice is this is a little more wordy than what you would get inside of Node. We have to annotate the mappings to tell it it's a get, a post, or a delete. Some might like that, some might hate it. You're auto wiring a service. This is a way of doing dependency injection, saying take the default setup. Some purists may say you shouldn't use auto-wired, and that is a correct answer. You can do constructor injection and setter injection. Many Spring developers I know use the auto-wired as is and just let the defaults load. So you also have the request body and path variable annotations here. Path variable tells you that when you see this ID and you call it in Postman, that you're going to look at this ID, match it up, doing convention over configuration, pass it to the service, and receive it back. That is very similar to what we see in the Node side with the request params ID and the colon ID. Just a little bit of extra configuration. This is not much different when you start to switch up and go over to working with, say, XML or key value pairs. In either case, you'd have to do extra configuration. Just in Spring, it tells you up front what you're dealing with. So the response entity is the same as going response status 200 send, but instead of saying the status and send, what we're doing is we're telling it what to return, and we're telling it the default code. This is intentionally left really simple. In a real production environment, you would want a lot more robust checking in here, looking for exceptions, having custom return codes based on empty lists or bad values. For the sake of simplicity, we're just taking the ideal path here. We have not written tests. We've not done anything that we would do in a more robust environment. For that, I'd recommend taking one of my courses. Those will be coming soon, and in there we'll be going through test-driven development, how to get all of these corner cases matched, exception handlers, writing exception handlers for the controllers, both on the Node side and on the Java side. So if we go into the repository layer, I was going to say service, let's go to repository. Again, this is a really super simple implementation. It looks here at the wait repository, which extends from Mongo. Again, convention over configuration with the wait class and the ID value being a string. If we control click in, we can see it uses data, and it uses a document telling you to use the wait schemas collection. Here we see all of our values again, and it knows that an ID is of type string. So we don't have to do any setup to get these because they come for free. In a production environment, you'd probably want to override your find, save, delete logic to add the custom handling of errors. For us though, if we look at Mongo repository, we see in here insert comes for free, find all comes for free, and they extend from the CRUD repository, which is doing SQL World. There's paging and sorting, there's query by examples, all of these are coming for free. So very nice, very similar to Mongoose. If we go into the service layer, then we see that we have our find by ID, or else give an empty wait. We return all of our objects and put them inside of a JSON entry and return that JSON entry. We do the similar when we want to find all waits. We run through a list, we add them in, we put them in an array, we return that array. This is akin to what we did here in the 2 lines. Since JSON was written for JavaScript, after all, JSON means JavaScript object notation, it simply makes sense that it'd be simpler to do in JavaScript. That being said, it is an interchange format used by many languages today, and therefore it's going to be a bit of a different implementation. Some will find they like the simplicity of JavaScript, others like the verbosity and the ability to communicate very succinctly what you're trying to do and what values you have. Now for the add wait, it's very similar, as in it's the delete to what we did in the JavaScript side. However, inside of the JavaScript side, it's more code than it is in the Java side. Here we had to pull the body, we had to add all the values, create a new date, and then save it. In the Java side, we simply have to create the new date and save it. In a production environment, you would want to use the required annotations. You'd want to make sure that you're validating the inputs, sanitizing it, making sure there's no garbage or nefarious code. But for this, we're simply trying to illustrate how an ORM works, so we're leaving that out. For the delete, we're looking at very much the same code. Delete many versus delete all, and the response codes are the same. So let's go to Postman now. I've already started the server and the React on the side for Node. But if we open up this Java program and it's running in Java 20, then we'll see it started. And if we scroll over, we will see it's running on port 8080. If we create a new HTTP request, localhost 3100, wait, we'll see it's empty. Similarly, if we go 8080 wait, it's also empty. Now, what if we were to do a post using our Node app? Well, we can go ahead and go raw, and we can add in all of our values. So we will have here a name, test node. We can have sets, 5, not 30. Reps, 30, weight. Since we're doing 30 reps, might as well do a lightweight, 10 pounds. And then if we send this across the wire, change this to JSON, successfully add the record. Well, if we get this value back, we now see our entries. You'll note in the node side, you have the under V and the under ID. These are things that Node puts out. Note the timestamp, 2023-09-02. If we go to Java and we do this, now we have ID but not under ID. For our purposes, we really don't ever want to be showing the ID to the user. We are, but that could create a bug. So we need to keep this in mind. The date also changed into an ISO style date. So that's another thing to keep in mind, sanitizing these when changing a backend. But if we were to post using the front end, the back end here in Java, and go test Java, we can also add the record, we can fetch it, and we can now see both records are in here. If we do a get on the node side, we can see the records are both here. But now what we see is we don't see the under V. We do see the date class changed back to the node format automatically. The reason why, the way Mongo stores it, is inconsequential. It translates it using the ORM to the conventions of the underlying framework. However, we see the under class came from the Java entry. So we can see Java created this rather than Node. But we also see now it translated it to underscore ID. So that worked as we'd expect. But the question is, will this work in the React side? If we go to React and we come into our components and we change out 3100 for 8080 and we restart the app, all we have to do now, probably don't have to restart this. I just want to be safe rather than sorry. Now, it just pulled in both of them. The IDs both failed. But if we were to add a new exercise, test React, and and submit this. It now shows up. If we go back to Postman and we query Node, we see test React. If we query JavaScript, or Java I mean, we see test React. The only difference is the ID. If we go to our console, each child should have a unique key prop. So it is giving us an issue about things, but it's not saying anything about the ID. So when changing out the ORM and changing out the backend, keep that in mind. The ID can be different. Keep it in mind the date can look different. But it is easy enough to switch it out without being concerned what's underneath. If you enjoyed this video, please give a like and leave a comment, share it with your friends, and keep an eye out because I will be blasting some comments when the course comes out on how to create a fully fledged system that's a more useful program that's full stack. If there's something else you wanted to see, please let me know. I'm always wanting to look for new things to do, and your feedback really helps me figure out what I should make. Have a great one.